Finding the Area, Part 2, Triangles. Greetings, everyone. Today we're going to dive into the fundamental yet intriguing topic of geometry and finding the area of triangles. This skill is not only essential for your teaching toolkit, but also for the general knowledge test. Triangles are one of the simplest yet most versatile shapes in geometry. Whether equilateral, isosceles, or scalene, I hope you know the difference. The area calculation principles remain constant, but require clear understandings and application. This presentation will focus specifically on a new problem format that has been brought to my attention that has recently been included in the GKT test. So let's look at this 4x4 grid on the screen. Imagine each cell as a unit square. This grid has helped us previously visualize and calculate such things as perimeter and area of figures with parallel lines. But of course, not all figures have parallel characteristics, such as a square. Today, we'll learn how to use this same table to help us calculate the area of triangles and evaluate the space both inside and outside of those triangles. Understanding how to work within this grid can offer a clear perspective on the geometric concepts we're about to explore. And of course, those common units, just as a refresher, common units of area might be centimeters squared, meters squared, feet squared, yards squared, etc. Or you may see them written out as square centimeters or square meters. So in the next part of our presentation, we're going to go through several examples that you may see on the GKT or something very similar. We'll start with the basic configurations and gradually move to more complex scenarios. I'll guide you through each step, ensuring you understand how to apply the formulas and techniques effectively. Before we jump into calculating the area of a triangle, let's first just do a little review on quadrilaterals. So as you can see, we have our grid to the right. It is a 4x4 grid, so the area of the grid, I think, is easy enough for you to calculate, is 16. 4 times 4 equals 16. So the question is asked, what is the area shaded in blue? Well, one easy way to do this is just we can notice that it covers, its base is 2 and its height is 2. So 2 times 2 equals 4 square units. We're counting our squares just as basic units. But what if we wanted to calculate the area of the grid that is not shaded? Going into question 2. If we know the total area of the grid, which is 16 square units, and we know the area that is shaded, all we would have to do is calculate the total minus the shaded area to find the unshaded area. And in that case, it's 16 minus 4 equals 12 units. And of course, you can always check your math on this one just by counting the number of squares that are unshaded. Let's now try that same process with triangles. If you remember, the area of a triangle is 1/2 times base times height. So we could also say 1/2 length times width. So to find the area of a triangle shaded in blue, as the question asks, notice it happens to be 1/2 the size of the grid that it's sitting in. So if the grid is 4x4, we know that if the grid is 4x4, the area of the grid is 16, half of that is going to be 8. So we can see where that formula of a triangle comes from and where that 1/2 becomes a critical factor in calculating the area of triangles. So again, We're asked, what is the area shaded in blue? This one looks a little bit trickier, but it's really not. We can always approach it from just our basic equation for our triangles. What is the base? We can count that it is 4 units wide and 4 units tall. So using our equation, 1/2 times the 4 units times 4 units is going to give us 8 square units. So let's now change that question just a little bit. What if the question were asked, what is the area not shaded in blue? Well, it sounds a little trickier. It's really not any more difficult than what we've been doing. We know the total area, which is 16 units, and we know the shaded area that we calculated for the area of the triangle that's sitting within our grid. All we have to do is find the difference, which of course is 8 units. And of course, on these problems, you're not able to easily count the squares that aren't shaded, so it will require some calculation and knowledge of geometry. Okay, what is the shaded area in blue? This one looks a little bit more scary, and it's this triangle that's sitting in the grid is not giving up any of its secrets easily. So we're going to have to use some of the same tactics we've done on the other ones to kind of tease out the answer on this one. So of course we know it's sitting in our 4x4 grid. So we know our total area of that grid is 16. So there's a known. We've also got these other triangles that are carved out alongside that shaded triangle sitting in the center. We've got A, B, and C are all 3 triangles that have those nice edges that we can actually use to make our calculations with. So what we have to simply do is take it in chunks. We know our total is 16 square units. So let's find the area of A. So we've got 1/2 times 2 times 4 units, and that equals 4 units. We can come down and we can solve for that triangle B that we've labeled. And that again is going to be 1/2 times 2 times 2. So that'll be 2 units. And then we come over to that third triangle that's unshaded, triangle C, and that is going to be 4 by 2. Don't forget to multiply it by 1/2. It is a triangle, so that comes out to 4 units. So we know we have 16 total. And if we add up all the unshaded triangular areas, we come up with 10 square units. So 16 minus 10 equals 6 square units that's going to be left that is going to be shaded. So a couple of extra steps, but some very, very easy math because we're working within that grid is giving us those nice whole numbers so nothing gets messy. Okay, that's going to be one of the hardest ones you'll do, but don't worry, you've got all the skills able to do it. And just as a reminder, these questions, from what I'm hearing, can be asked in many ways. They may even have one picture and have several questions attached to it. So they may ask you for the shaded area, or they may ask you for unshaded areas. It's the same process. Don't let it overwhelm you. It's the same process to finding the solution, whether they're asking for shaded or unshaded regions. That does it for this episode. If you do have any questions about this or anything else that might be on your general knowledge test, you all know where to find me. Thanks for watching.